Okay, good evening, friends, and welcome to Pharma Analytics program. So today we'll be seeing text mining in Pharma Analytics. So as we know, healthcare databases are growing exponentially day by day, and text analysis or text analytics and NLP system transfer or turn this data into some kind of value. Okay, these are just unstructured data which we can turn into some kind of value. So the healthcare provider or pharmaceutical companies or biotechnological firms, okay, all use text analytics or NLP to improve patient outcome, streamline operation, and manage regulatory compliance. Yeah. So what are the data sources, okay, which come under this? So if we are talking about data sources, we are having many data sources like patient health record or order entries, physician notes. Okay. Apart from this, we are also having data like, genetic information. So 26 million people have already added their genetic information to commercial database through take home kits. Okay, there is also data from wearable devices like smart watches, uh, Fitbit and all. So yeah, they have also opened floodgates to consumer health data. So it is a veritable gold mine of healthcare. We also get data from IoT sources like Fitbit data. We are also getting data from electronic medical records, EMR, EHR, okay, electronic health records. We are also getting data from insurance providers. We are also having data in clinical storage of data, okay, like computerized physical order entries, physician notes, medical imaging records, etc. We are also having data in genome and research registries. Also, we find data in social media. Also, we have data in web knowledge, okay, like emergency care data, news feeds, medical journals. Okay, so we need to extract this data. So according to this research, more than 2314 exabytes, okay, more than 2314 exabytes of data are being produced every day. Okay, and this 2314 exabytes of data is produced, and 1 exabyte of data is equivalent to 10 to the power 9 gigabytes. So just think how much data is being produced. Okay, and we are having all of this data. So someone needs to, make sense of this data. So that is where text mining comes into being. So let us see what we'll be learning today. So first of all, what is the importance of text mining? We'll be seeing what are bag of words, what are the terminologies and pre-processing related to text mining, what is DTM and TDM, what are corpus level word cloud, what are positive negative word clouds, what are the use cases and inferences from those use cases. We'll be seeing all those things. Okay, so next moving to importance of text mining. Okay, so during COVID, most of the work was done from home. Okay, and social distancing measure also brought our relations online with digital channels. Okay, so we mainly interacted through online or digital channels. So a lot of data was generated from these interactions. So text analysis helps business to analyze these data or text-based data in a scalable, consistent, and unbiased manner. It analyzes data and extracts valuable information from it. So what are some of the textual unstructured data? Where can we find this? You can find this data in call transcripts, email services, social media, okay, speech transcript, salespeople, interviews or surveys, okay. And what are we looking to mine from this data? What are we looking to find out from this data? So from this data, we try to find out topics. What are the topics or themes related? What is the sentiment behind this, text? What is the relationship or facts behind this text? We also try to find named entities like people, companies. We also try to find document authors from metadata. We also try to find phone numbers and many other things. Next, coming to bag of words. So what is a bag of words? Simply put, it is a simplifying representation which is used for NLP and information retrieval. So bag of words is, you can say simply it is a bunch of words, okay, from a sentence where we disregard the grammar, okay, and not even in the right order we put the words, and but we see the multiplicity of these words, means how many times it is occurring in the sentence. According to that, we decide that this word is more important than others. So this is what bag of words is. Okay, it is used for language modeling and also document classification. Now each row, okay, each row is considered as a document. Even empty row is considered as a document, and collection of all those rows is known as corpus or corpora. Okay. Then we have stemming. Stemming is a process where we consider only stem words. For example, if we are having jumping and jumped, we consider jump as the stem word here. Okay. Now, quirks of language, there are many kinds of typos. We try to correct this. Lowercase, proper case, uppercase. We also try to look into this. Then we are having punctuation symbols. We try to delete this. Filter words, connector pronouns. We also try to delete this. This comes under stop words. Okay. We will try to eliminate these words. What is term frequency inverse document frequency? Okay. So before that, we must learn what is this DTM and what is this DTM? DTM is document term matrix. In this, we are having two methods, term frequency and term frequency inverse document frequency. In term frequency, we just count the regular term, how many times a term is occurring in a review or something like that in a text. And this term frequency inverse document frequency, here we calculate, you can say term frequency as well as how many times it is occurring in a document. That also we calculate. So let's look at this example. In this example, we can see this one row is a review. In this review, we can see keyboard is occurring 4 times, USB is occurring 1 time, free is occurring 0 time, and hand is occurring twice. Okay, similarly for second row, keyboard is occurring thrice, USB occurring once, free is occurring once, hard is occurring 0 times. Okay, just by looking at this 100 rows. Okay, let me change the color. These 100 rows, Okay, from this we see that this term is occurring 200 times. This term USB is occurring 50 times. This free is occurring 100 times. This hard is occurring 80 times. So if we count this document frequency, okay, so document frequency is term frequency, or term, this term sum 200 by number of this documents 100. Okay, so we see document frequency is 2 here. Similarly, here it is 50 by 100, which is half. Okay, so likewise we calculate all the document frequency. Okay, now coming to this TF IDF. So TF, we just calculate this term frequency, how many times it is occurring. Consider this, for this TF IDF, we are considering this 50 and 70th term. So in this we see keyboard is coming twice, and in 70th term we see USB is coming twice. So we can say that, yeah, these two are having same importance because they are coming twice. Okay, but this is not the case. So if you check what is the document frequency, okay, it is twice here. So it is coming twice in 50th row. So it is not that, it is common basically. Okay, so average score, when it is closer to average score, it is a common phenomenon. But just look at here, for USB we are having this 4 times of the average value, this value. So by that we can say it is more important. Okay, but here also we can calculate this by inverse document. So just take the inverse of this. So inverse of this is 1 by 2. Inverse of this is 2. Now multiply it using the inverse document. So half, half, half. So let's check for this. So it is coming out to be 1. Okay, so it has 1 times importance if you are considering like that. And this has 2 into 2, 4 times more importance than this number. 4 times importance. So like this, we calculate this. And after finding this, okay, after calculating all of this, we try to find the word cloud. Okay. Yeah. Next, we'll see word cloud. So what does a word cloud show? So this is a word cloud. This is a corpus level word cloud. So here, whatever words are occurring frequently will be shown. So more frequent or more frequency a word has, okay, more frequency a word is having, the larger the font will be. Larger font it will have in this word cloud. So if you can see here, I think good is having the most bigger front. I think game is having the most, larger font. So game is occurring many times. Similarly, yeah, okay. So here we can see whichever is having the largest fund is occurring multiple times or more times. Here we can also do sentiment analysis using this word cloud. How to do that? So for sentiment analysis, we calculate positive and negative sentiments. How to do that? So for that, we'll have to download for that, we'll have to download positive and negative word, which is positive, which is word dictionary, which is easily available online. Publicly, it is available. You can go and download this. So what we do, this algorithm, okay, text mining algorithm will map all of our DTM or this document term matrix. Yeah, it will map all the terms here in document term matrix to this positive word dictionary, and wherever it find match, it will show. Also, it will capture how many times it is occurring. According to that, okay, it will show a bigger fund, like we are doing here. Okay, if it is having higher count, it will show us a bigger fund. If it is having a lower count, it will show us a smaller fund. Okay, that is how it works. Occur more than others. Here we can see hard is a term. So yeah, this is our sentiment analysis, in which we can tag all the positive and negative words. Now let us talk about the use case. Okay, this was related to claims. So here we are producing a drug. Suppose COVID-19 drugs. So it has to go through all of this process to be in the market. So what happens? First, these drugs will be tested on animals. Okay, if it passes this test, next it will be tested on humans who are having very few specific diseases. Sorry, humans with that specific disease. For this is, suppose a human is having COVID. So for them, it will be tested. If this is also pass, next we'll do this test on humans having other diseases which may be affected by this drug. So suppose a person is having a diabetes. Okay, so the drug will be also tested on them. Okay, if here also it is passing, then we can go for larger audience. Okay, once it passes here, then it can get licensing from the US Food and Drug Administration. Okay, and it can be it can be sent to the market. Suppose after this we are seeing some adverse events. Okay, then what happens? Suppose like adverse events, like suppose after eating the medicine I'm getting some kind of infection in my body or some kind of rash, suppose, in my body. So this is the work of a doctor or responsibility of a doctor to report this. And if many doctors report the same, this side effects, this medicine or this drugs will be shut down. Okay, so this is the stages through which every drugs goes through. Now let us talk about this clinical project. So here we are trying to increase the success rate of a clinical trial. Okay, so first of all we downloaded data from this open source forum clinicaltrials.gov, and from this we got an XML file. From that we have segregated the data into structured and unstructured data, and we have performed word cloud and sentiment analysis on this data. So from this we want to identify what are the reasons for termination of clinical trials. So here we have used term frequency as well as term frequency inverse, document frequency, positive negative word cloud, Dendrogram, k-means clustering, semantic network. Okay, so let me first show you this, how to download this data. So just a second. So this is the website for clinicaltrials.gov.in. Okay, so I'll download a data from this. So let us take this data. I've selected this. I'll download this. I'll take it in XML format. I downloaded this. It has been downloaded. Now I'll just open this. Go to downloads, open. Okay. Let me open this. Okay. Okay, so this is the data which I have downloaded. You can see this is a unstructured data or semi-structured data, you can say, because it has some schema. This semi-structured data, if we see here, suppose the condition, what is the condition and what are the interventions we will be following. So let me search condition. Suppose let us take yeah, let us take this condition. Plasmodium falciparum infection. If I am having this, okay, this is a malaria condition. If I am having this condition, so what should I do? So what should I do is intervention. intervention type is drug. So I should take this L9, L5 and other, what can I take other than this normal saline if I'm having this condition. So this data contains something like this. Now, just looking at this data, okay, we have taken a similar kind of data, then we have done this. Okay, so from this, we saw the words like accurate, enrollment, terminated, slow, okay, safety, efficacy here. Okay, we have seen this sponsor, lack, low. Okay, so these words for gaining business value, we also drew a dendrogram. Okay, from this, if you see why it was terminated due to slow enrollment and slow accurate. If you see this, slow enrollment, slow accurate. Okay, when we saw in dendrogram, we noticed slow accurate, slow enrollment, poor efficacy, sponsor funding. Okay, due to this, that clinical trials were terminated. Now let us, so that was Unigram or one word analysis. Now we will be talking about Bigram. Okay, because Unigram may not be that much clear. So we'll check for Bigram. Okay, what is Bigram? Bigram is two word cloud. Okay, here we see two words are coming together. Okay, so here we are seeing something as safety concerns is showing up. Okay, so if you just see this, it may seem that safety concerns may be a reason for termination, but when we saw this in this in text or the original file, we saw that it was written no safety concerns. Most of the places it was no safety concerns. So the thing is, we should see it in context before deciding on this. Okay, so instead of this, we could have gone for trigrams so that it would have been more clear to us. Next, we did k-means clustering on this whole data. Okay, from this we found out different clusters. So we found that two clusters and we segregated that into two different clusters, and then we did analysis on those two clusters. And from this we saw that word cloud was clearly highlighting in this cluster, okay, about accurate, okay, or the term referring to number of patients in study or clinical trial. And even the dendrogram also showed accurate and enrollment and slow as a major cluster. If you see, it is not clear, I know, but yeah, it is there. Accurate, enrollment and slow forms a major cluster. Okay, this is the one here. This cluster, accurate, slow enrollment. Okay. For the next cluster, this is for first cluster. So we have segregated into two clusters. This is the first cluster. This is the second cluster. Doing analysis on the second cluster, okay, we found in this that it was terminated with words related to early and premature. Dendrogram also shows this premature closure of clinical trials. Due to this, it was closed. This clinical trial was closed due to premature closure. So through this, we have decided that these are the reasons for, this termination of what this clinical trials. Now from that, we also found the positive word cloud. Okay, so I found that positive word cloud, like good, it is a unigram, this is a bigram. We found good experience, okay, and likely we also find the negative word cloud, in which we had like problem, doubt, worst, disappoint. Okay, basically those are sentiments we are trying to look for. So from this, we also learned about the structure of text data and how to use bag of words. We learned about terminology used in text data analysis. We learned about DTM, TDM. We learned about DF, IDF and its usage. And we also learned about word cloud and its interpretation, along with, this positive and negatives, or you can say sentiment analysis related to word cloud. So let us see open that up. Okay, so here we'll be using Beautiful Soup, which is a Python library to pull data, okay, HTML or XML data, and the parser we are using here is requests. So we'll be doing this. So here what we are trying to do is we are trying to extract reviews from drugs.com of different drugs. So I'll be showing you just for one, and the business objective here is text mining analysis using reviews or sentiment analysis, you can say. Okay, so let's see. First, I am importing requests. Okay, so it will extract content from a which is used for web scraping, and I'm also using regular expression. This is RE's regular expression to do text manipulation. A regular expression. Okay, we are also in matplotlib to show different, this visualization, and we are also using word cloud to show the word cloud. Okay, so I'll just run this. Next, I'm creating an empty list which will store all the reviews from this. Okay, let me first show you what we are taking. I'm taking reviews for Xanax, which is a drug, So for this Xanax, I'm taking this reviews of different people from drugs.com website. Okay. You can see this is the URL which I have taken, same URL from here. Okay, xanax.html. Now this function I'm using to record all the reviews. Okay, if I run this, it will record all the reviews. So let me run this and record all the reviews. Some time to run. Okay, so yeah, it is done. From this drugs.com, this page, I am extracting all the reviews. Not just from this page, multiple pages reviews I am taking. Okay. Now let us here. Yeah. Now the reviews are recorded in this drugs reviews. So next I'll be using this regular expression to remove all those unwanted symbols. If it is existing, we want to remove this. So for that I'm using regular expression. So I'm saying if all of this, any of this is present, just replace it with nothing, empty string. Okay. So I'm running this also. Here also I'm doing this, this TF IDF vectorization. Okay, I'm converting that also. And here the corpus level word cloud I am generating. So you can see from this corpus level word cloud is being generated. We are having Xanax, anxiety. Okay, these are coming maximum number of times here. Drug. So let's do sentiment analysis. Next, we are trying to do sentiment analysis on this using positive and negative word cloud. So for positive word cloud and negative word cloud, we need to also have this positive words text, which is a dictionary. As we discussed earlier, it is a dictionary for positive words. All the positive words are contained in this dictionary. Okay, I'm running this. So here we will get the output. I'll run this. So here a word cloud will be generated showing us all the positive words like work, help, great, okay, amazing, good, miracle, worked. Okay, these are all the positive words which our software detected. Now coming to the negative keywords. Okay, if I see this negative keywords, depression, panic, attack, anxiety. Okay, all these terms it is looking at as a negative keyword. But let us also look at the bigram. Okay, let us look at the bigram or word cloud. Okay, so for this I'm also using lematizer. If you remember, lematizer. Of example, we had jumping and jumped. If we are having two words, it will just take jump twice. Okay. So that also we are doing here for Bigram, so that no words are repeated again. Okay, and from this, when I'm running this, these are the bigrams we are getting. If you see, okay. So this I'm joining to convert this into a list. I'm using bag of words to count how many times this. Next, I'll be generating the word cloud on this bigram data. Okay. So I'm generating. So according to the frequency, it will give us the word cloud. So let us see. Here it is generated. I'll have to also run this to create it. Okay. So here I have created a word cloud, word cloud. This is a bigram word cloud. So here we can see taking Xanax, panic disorder, panic attack, anxiety, panic, Xanax here, anxiety, depression. Okay, these words are occurring regularly. So just by seeing this, you may think that this is a negative review. These are having negative reviews. Okay, when we did the Unigram analysis, we saw that we are having many negative reviews. But after we did the sentiment analysis to find positive and negative sentiments through reviews, okay, we saw some positive words and some negative words in those. To get a clearer idea, we did bigram there. So it gave us a clear idea, means we are getting some panic attack and all. But we will have to look at this with some context. So if we move to this context, okay, so if you just read through any one of them, you will see that most of the places it is saying that most reviews are relating to panic attack or anxiety attack or depression. Okay, and it shows and it is written that taking Xanax helps. Okay, so what I'm saying is, for reviews, it may show as a negative review or a positive review, but you will also have to see under what context it is being used. Okay, so sometimes a word might appear in both the positive and negative reviews. Okay, so for example, we had done a word cloud analysis. On that, we had something like cheap, a word cheap. Okay, and positive and negative. Positive we had cheaper, negative we had cheap. So when we went through the this reviews, we saw that it was cheaper than similar products, something like that. So it is a positive review. It is cheaper than similar products. And this cheap was like, this looks like a cheap China product. Something like that. Okay. So this is a negative review. This was a positive review, but words being used are same. So you will have to look at the context of the text to know it greatly. So if we had done trigram, suppose, okay, we would have gotten a more clear idea on this. Yeah, and friends, you can go and answer. I think some question must have been posted in the chat, or it will be posted. You can go and answer them. Okay. So let's just see this more clearly. So I just went through the overview. Let's see this more clearly. Okay, for positive words, what we are doing. Okay, we have downloaded this word cloud dictionary. Okay, we have downloaded this word cloud dictionary. Okay, and we are then comparing okay our DTM or document term matrix. So comparing with this document term matrix to match and find all the positive words which is occurring in this, and also we are trying to find the count of it or the frequency of it so that we can make our word cloud accordingly. Yeah, friends. So this is how we do this positive words. Similarly, we'll do for negative words also. So let me show you. This is the same thing we are doing for negative words. We are downloading this negative words, which is a publicly available dictionary file or text file, you can say negative words. Okay. And we are comparing this with the DTM document term matrix and finding out all the negative words along with frequency. And accordingly, we are making the negative word cloud. Okay. And by this, we are making sense, of these reviews, which are not in a structured format, not in a structured format. Okay, we are extracting inferences, and we can use this inferences for, you know, uh, uh, yeah, we can use this inferences for further development, you can say. Suppose a drug causes some side effects. Okay, so from this user reviews, we can extract, we can find that it causes itchiness, suppose. Okay, and we can use this findings to ban these suppose medicines, or let people know of these issues. Okay, so that way it is very much useful. So friends, you can, I think a question must have been posted. You can go and answer that. Yeah, so friends, that was all from this text mining session. Please follow us and, you know, join us next time. Tomorrow same time we'll have another session. So yeah, thank you friends, and have a good day.